Thanks for having me. So one of the side effects for me coming over to Canada is that we don't have Macintosh apples in Hungary. So I finally had the chance to taste the apple that gave its name to Apple. It's very tasty, by the way. So all this environmental impact came up also yesterday in the hallway track and now on the keynote. One thing I started to do a few years ago, and I just hope it makes a difference, is like you can subscribe to a service. I use Ecology, but there are other services where you pay like a monthly fee and they will plant trees for you, they will invest in renewable energies and stuff like that. So maybe it can help offset your CO2 footprint. But to my talk, the title is Finding Vulnerabilities in Apple Packages at Scale. My name is Csaba Fitzl. I live in Hungary and I'm working for Kanji as a principal macOS security researcher. I do vulnerability research most of my time. So for one, it helps the entire community make the Mac more secure, and we also try to come up with ideas into our EDR product to actually mitigate and protect against not just those exploits I find, but more broadly catching stuff. Before that, I used to work for Offensive Security, where I wrote a macOS exploitation training. I used to be a red blue teamer, and I'm do macOS bug hunting. Now close to 100 CVs. I'm married, have 2 kids, and I'm really into hiking and trail running. So warning, macOS systems were harmed in the making of this talk. Only my systems and probably those people who test my submissions at Apple. So this talk has a rating of R because of violence. So it's a really long presentation, so I will really rush through many parts. So I will briefly go through the Apple security model because I think this audience knows that very well. Then talk about system install, a few past vulnerabilities, then the software catalog, how I use ChatGPT in helping me looking for vulnerabilities, and then I will cover 5 different vulnerabilities and how Apple mitigated them and what is their general strategy to mitigate package related vulnerabilities. So this will be really brief because I think here everyone knows this. So macOS, that's not your typical OS. It has a POSIX heritage. Root is kinda an admin user with some more privileges, but it's not like a god as in other POSIX systems. We have sandbox, TCC, SIP. We actually have security boundaries on this platform, like from normal user to admin to root to kernel. Unlike on Windows, where if you are any type of admin user, going from medium admin to high admin to system to kernel, there is no security boundary on Windows in that chain by design. And process injection is generally not allowed. Everything is based on code signing, and entitlements are widely used on the system. Basically, they are giving you specific rights. So maybe process X can talk to process Y. A specific entitlement can give you access to like writing to this location or accessing this and that resource. Maybe you can install a kernel extension, whatever. So basically permissions can go really, really granular with entitlements. SIP, known as rootless, is basically a global sandbox for every process on the system, including Apple's own processes. Basically, the main goal originally was to protect core system resources, but now it's much more broad nowadays. So basically, root is no longer root because it cannot modify core system files. And some entitlements will actually give you a bypass for SIP. Traditional sandbox, the application is containerized. It can only access its own container or folder with a few exceptions. Also network, other files are based on extra entitlements the developer provides. TCC, we love and hate it. At the same time, I think it limits basically access to all of the private resources on the system, all those annoying pop-ups, but it's also hilariously broken. To be fair, not TCC is what's broken, but too many processes have exceptions. So if you find a vulnerability in any of that daemon or process, basically you get a TCC bypass. So this just all over the place. So system install D. This is daemon which is responsible for installing Apple signed packages. So basically all of the packages that Apple will distribute, including the operating system update or just even like Xcode command line tool installers. Now, it has a bunch of entitlements, but has one very interesting, which is called com Apple rootless install heritable. Now, this gives this daemon an exception to write to some of the SIP protected locations, like library Apple or any of the TCC databases or many other places. And the heritable tag means that any process that will be spawned by system install D and down to the chain, they will inherit this specific entitlement. So the idea is that many of the packages that are being installed will be installed by system install D, and if those packages contain scripts, those scripts will be spawned by system install D. And if those scripts have vulnerabilities, we can basically gain access to this special right. So what we will try to do with all of the vulnerabilities and exploits coming up is take the hello application list plist file, which was an unused TCC database up to macOS Sequoia. It was empty for many years now. I don't think it was used by anything recently other than me abusing it for extra TCC rights. So basically, if you added any entry there, like full disk access to terminal, that will be the goal here, actually. It was taken by TCC, and you got these rights. And actually, whatever you put in there, it doesn't show up in the security and privacy pane on system settings. But they realized that it shouldn't be there because it's just me and few other people messing with that. So they actually removed this plist file in Sequoia. So few past vulnerabilities regarding package kit or vulnerable packages. Back in 2019, I think Jerome Bradley was the first one to actually pawn. Basically, he could swap a package in the middle of the installation, so he could install his own stuff with SIP bypass privileges. Then in 2020, there was an install script exploit where you could execute a custom binary through the installation script and again gain SIP bypass privileges. 2021, Shrootless from Jonathan Barr from Microsoft, he basically modified the etcnv file, or actually added an entry which was consumed by the Z shell process when the script was running, and again he gained SIP bypass privileges. And a few others. And then there is Mickey Jean. He's have like over 50 CVs on package kit. Like, he's crazy. On that, he's not just finding stuff with packages, he's mostly focusing on the actual framework and exploiting vulnerabilities in the framework itself. So, the software catalog, how do we get packages from Apple, signed packages from Apple? We can go to developerapple.com, download, and there are a few, but it's very limited. And there is also support apple.com, but again, it's a limited set of packages. Until last year, I read a blog post about actually someone doing very similar research than I did. Michael Cowell basically analyzed the entire software catalog and looking for vulnerabilities. And he was like writing a sentence that like dumping a list of packages from Apple's software catalog. And I was like, what the hell is that? Probably many of you actually know that because that's more known for the sysadmin community, but I didn't know about it. So it turns out it's a software catalog containing a whole lot of Apple packages that you can download and install. They have this is the typical URL for these. Every OS has their own URL where basically they list all the operating systems down to Leopard, where the highest number is the most recent OS. It's a huge property list in XML format. It has a list of products. They have a key, which is a number. They have a size, where they give you the size of the package, and they give you the URL for the package, and the post date when this package was first posted, basically. So the challenge was like, Michael did analyze the entire catalog, but I was like, okay, but what if there are still vulnerabilities left? I keep finding vulnerabilities in components that I already looked at once. And there is a ton of packages. So I was like, okay, I need some automation to process all of them. And I really suck at automation. So I was like, okay, we have stuff called like ChatGPT AI, which I never really used. I was really skeptical, but I was more lazy than skeptical. So I was like, I will give it a try. Let's see where we are going with that. So step 0, I was like, okay, let's get the XML and let's parse it. The first step was to actually get all the URLs for all the software catalogs, and there is like a GitHub gist where you have the list of all these. So I was like, okay, download this page, parse it, and get all the URLs for all the software catalogs out there. And in like 2-3 iterations, it got it. So I was like, okay, we will get somewhere. Next one, I was like, okay, we need to parse this XML. I want to know how many packages I need to download and analyze. It eventually got it. It even knew the basics of the XML structure without me telling it how it looks. So it turned out that there is 10,000 packages, different packages in the software catalog, which was like 1.3 terabytes of data. Luckily, I have a big hard drive and a fast internet connection, so I could like get it in a day. Okay, now came the work that, okay, I have 10,000 packages. There is no way I will analyze them one by one. I need to go through them quickly, or at least somehow automate and filter all those out which are not interesting. And because I was looking for script vulnerabilities in packages, because you usually have like the payloads, which is like being copied to its final location, and you have the scripts which are doing some stuff. So I was like, okay, if the package doesn't have any scripts, I don't need that. So I can just delete them. Actually, I started to log all the packages I deleted, just in case I need to go back to them in the future. So this was again a short script made by ChatGPT that again went through all the packages and deleted those without script. Next one, I need to get rid of all the unsupported packages. So in the old operating system, like up to Catalina, I think, you could actually write to /system, because although they were zip protected, they were still read-write mounted. Maybe it was up to Mojave, I don't remember. And actually some old packages did install some files under system. Now this doesn't work in the latest version of macOS because we only mount the snapshot, which is by design doesn't support write operation, so it's read-only, it's zip protected, and it's also mounted as read-only as an extra. So there is no way you will write to /system. So if the system detects that the package is trying to install something to /system or /usr, wherever, it will say, okay, this is an unsupported package, I bail out, I will not do anything. So all these packages are not interesting. Delete them all. Some packages have a default pre and post install script which only contains some default logging, and they are not vulnerable. So I was like, okay, if the packages only contain these default scripts, I can get rid of them. Then there are other files, some plist files, star files, zip files, which actually contain all package types. Looked into a few, they were not interesting, so again, just delete all of them. PPD files, they are PostScript printer descriptor file, can be found in printer packages. I did take a look into some of them, but they were not interesting, so I was like, okay, if the installer only contains these PPD scripts, I can get rid of those packages as well. Then remain the rest, so we are down to like 300 to 400 packages from 10,000, which is actually manageable. So I started to analyze them one by one by hand. Now I probably didn't look at 300 packages because there were still a few duplicates, so I could still remove a few on the go. So probably it was closer to 100 to 150 packages. So now to the actual vulnerabilities. This was in the iDVD extra content package, and this gave us full zip bypass. Again, the goal was always to override that TCC plist file. So it contained two scripts, now move teams aside and now copy teams back. Basically, it was a script to backup and restore teams, iDVD teams you have on the system. The problem is that it was working in a user controllable location like library application support iDVD. So what it did, it basically created a temp folder where it backed up the teams, and at the very end, using ditto, it restored the teams. Now, during the restoration, we can, since it was working in a user controllable location, like not zip protected location, I could drop my own stuff in the teams folder, and the destination folder, I could swap it with a symbolic link and redirect it to that plist file that I wanted to overwrite. So basically it was a race condition, waiting for the ditto to restore my not real team to another location I wanted. And this is how it looked. So all of these exploits or vulnerabilities required root access. So we can see that terminal doesn't have any access right now, because you need to have root to install packages. But again, root is not God on macOS. So we don't have access to desktop. Now the installation is going on, and pretty much that's it. And now we have access to desktop. So the next one was actual printer installer, Canon Laser F-Core. It wasn't a full zip bypass. It just allowed us to overwrite an arbitrary zip file. What it did, it was really simple. It created a log file in the temp directory. Again, the temp directory is under your control. It had a fixed file name for the log file, so you could just create a symbolic link at that log file and point it anywhere you wanted, and wherever you pointed that log file, that file was overwritten. So it's only like a denial of service attack, but you could overwrite like xprotect, so you could disable xprotect or remove anything from library Apple directory. Next one is recovery HD update. Now this was a full TCC bypass or SIP bypass again. It has a replace recovery script, and again it was working inside the temp directory, which is under our control. So what it did, it dropped the DMG file into the temp directory, and it mounted that DMG file also inside the temp directory. So you can see that it will use pkgutil to expand and extract the DMG file, and then it will call HDIutil to actually attach it to its location. Now what we could do here is look for this Perl script being launched and stop it, replace the DMG file with our own DMG file, and then continue the script. And also we could redirect HDIutil to a location of our choice, again to this LO list plist directory, and at the end just restart DCCD. So again, the same story. Terminal doesn't have any access, and that was pretty much it. And now terminal has a whole lot of access. This is a secret TCC talk, in fact. Okay, there is another one, remove desktop admin. It was also vulnerable for like SIP bypass. Now, this was already fixed when I found it, but I don't know who found it first because there is no public information about it. So I don't even know the CV associated with it, this and who found it first. Basically what happens here is it had an alert or install script which used the user environment variable. Now interestingly, you could inject the user environment variable into the installation process. So by injecting basically a custom user, you could inject a command to this sudo -u user alert or target, because the user doesn't have to be a re-user, it can be a command. So you can inject a command into that sudo part, and it could do whatever you wanted. So pretty much the line here was the entire exploit. You just say, okay, root script file, wherever your script file is, installer pkg, whatever, and then your script was executed. Yeah, again, overwriting the same plist file. I will not show this video because I want to stay in time. Last one is another printer driver, again full SIP bypass. What happened here? Again, this is also a vulnerability that was fixed by the time I found it, but again, I don't know who was the first reporter of this. So what it did, it took a PEX file, which is a compressed image. I never heard of this before, but it's like a compressed file, like zip files, and it will extract it. Now, I can control the PEX file, so I could drop any PEX file I wanted, and I could control the destination where it extracted the file. So it was like, I can drop any file in anywhere here. Same story. This is a Ventura machine, and I think this was like fixed long time ago. Yeah, this is as so. How Apple started to mitigate these vulnerabilities, because the problem is that all of these are valid packages. I think they used the same certificate to sign all of them, so they couldn't just revoke the certificate of the package, because that would like invalidate all of their packages at once. And also, if they fix the package, you still have the old package signed, and if you install the old vulnerable package, you can still exploit that. So you cannot, I mean, you can fix it on the package level, but it doesn't solve the problem on the OS level. So they had to come up with something that will solve the problem for the entire operating system. So you can't re-exploit the old vulnerable package on newer version of the OS. So what they did, they introduced 3 different configuration files in the package kit framework, where the first of it was the install script action plist file, which basically specified if this is the package and this is the script name, disable zip for the installation process. So drop zip for that process. So it means that it will not run anymore with zip bypass privileges. So even if you try to exploit it, you won't be able to, because it no longer has the required privileges. Next one was called, or is called, because it's still in place, install script mutation. This is used for only one package. It basically contains a regular expression that if you have this script, find this and replace it with this. So basically, they patch the script on the fly. And the regex is like, this is the whole script, match on this and replace it with this. So it's like, it works, but again, they did it only once. And the latest addition to this is the install script tries, which is probably the best solution, where they just say, okay, if this is the package, just drop zip. We don't care about the script or anything. They don't need zip bypass privileges, so yeah, just drop it. One more thing, I posted this yesterday, and let's see, it's Friday the 13th, so I'm not sure if live demos are working today, but I have a recording. This is totally unrelated to package kit, but it's a vulnerability I submitted yesterday, which works on macOS Tahoe, and it's a privilege escalation. Now, I had to obfuscate the output of the exploit because I don't want to reveal what's happening. So it's just doing magic, creating magic even more. And I hope, yeah, it did work. Okay, live demos work. And yeah, this is the backup. Thank you. That's it. One note, you can find me here, you can find me on LinkedIn, but I usually don't accept connections on LinkedIn unless you come in person to me and say that I want to connect with you, because I just usually reject people there. So yeah, I'm happy to connect with anyone, but then please come in person. Any questions, or we don't have time?
No, we have time.
Okay.
I have questions. I think Zach had a question he was holding on to.
Hey, thank you. Awesome talk. You were talking about the mitigations that Apple added. It seems like they, to my understanding, they added a deny list for certain packages to drop the permissions. So then the default is still to allow these permissions.
Yes.
And so then do you expect that we'll see more packages in the future that continue to have the same kind of class of vulnerabilities?
Yes. Yes. I actually submitted one on the, so I found one on the flight here. It's a new package. Yeah. Honestly, I don't know why they don't look at the package, and if it doesn't need to have this privilege, they just add it to the deny list by default, or do it the other way around.
Yes, the default deny and then
Yeah.
add the permissions with a careful audit of the script.
I think eventually we will land there, because usually that's what they do. They start to close such gaps one by one, and eventually they realize, okay, just deny everything.
Nice, thank you.
Any other questions? I have one question, Csaba. Where was the AI in that talk? I was promised AI.
ChatGPT.
But what did
Okay.
you ask it? What did... Oh. I was
Yeah,
like,
it
Did I
had me to
blink?
basically write. Yeah, I didn't
Stupid
put
question.
a weight on this, but yeah, basically all those scripts that helped me to cut down the number of packages were written by AI.
So for the slow people in the audience, I mean me, you were just feeding ChatGPT the install scripts and just looking for certain things like temp?
No, I told it that, okay, find all the packages that have no scripts. So it wrote a shell script that extracted all packages, checked if it has a script or not, and if not, then deleted all the extracted stuff and deleted the package. And I used it for every single step here. So all of this stuff were written, so all these scripts have beautiful comments. I'm not doing this stuff. So comments, echoes, prints, it's beautiful. Look at that. Anyone can understand this. If you provide it, it's not like any of my other exploits.
So you're saying that you just used it to get the scripts and then you just looked at the scripts in the old way with your
Yes.
brain. Okay.
Yeah, so actually looking at for vulnerabilities in the install scripts, that was done by me, but to reduce the number of packages I need to take a look at, that was done by.
So there's no takeaway AI prompt to just look for vulnerabilities. You're not going to give us your cheat sheet, right?
Yeah.
Oh, smart.
So the problem is that you could look, write some automated scripts to look for very specific vulnerabilities, but there is no generic way or generic theme for this vulnerability.
Can we train it on your brain or your blog and then... one more question.
Yeah, I mean, I sort of working. I have a related question. As wondering, in your role as a security researcher, if you were to ask ChatGPT or some other AI LLM to help you find vulnerabilities, have you tried that? And will it, or do you hit the safety constraints and it just refuses to?
I think I didn't try to find vulnerabilities with AI. Other people did.
Right.
They have a limited success
Like-
with that, but I do use it to actually write the exploits nowadays.
Will it ever refuse to help you?
No, because I'm not telling it that I'm writing an
I see,
exploit.
yeah.
I'm just saying.
Yeah.
I'm just saying that, hey,
It-
write this Objective-C code which does this.
Does it ever figure out what you're trying to do? And
No.
yeah, interesting. Okay. Yeah. That's what I was curious about. Yeah.
No.
Yeah. So
It
in other
looks
words,
legit,
attackers are probably doing the same thing.
Oh yeah.
Yeah.
I'm pretty sure.
Thanks for explaining it for us. Thank you so much, Csaba. Thank you.